Okay, after half semester, I think I gave a lot of tutorial on biology part. Too much. So for chemistry and geology, I'm going to combine into one tutorial that I'm going to give next week. Okay, so because for the first few weeks of lecture, it was on statistics, right? It was on all the tests, it was on how to do analysis, what kind of statistical modeling. So after that, we go into different kind of component in marine science. So it started off with marine biology, and then this week is geology, and then next week is chemistry and further on. But most of the time when we talk about data analysis, it's different for every component. So I am a biology background base. So most of my works are related to look at biological component and how does it relates to environmental. So it is more to regressions, R value and P value, is it significant or not? So as I go into geology, what do you really understand on marine geology? Apa yang terfikir pada kepala anda bila kata geology marine? What are the key points that you think of that you all can post into chat room?
Pasal rock, sediment, pasal tectonic.
Rocks and sediment. Yeah, so it is more to something that you can touch and feel, right? That you can see. But biology, sometimes you can see big one like corals. Sometimes you see them under microscope, small ones. And then comes to DNA and other stuff like things that you don't see. Okay. Sediment core. So pasal sediment. Let me share my screen too. This. Okay, then I open chat room. So the chat room is about batu, sediment, and sediment core. Okay, so I read a few papers and tried to analyze what are the analysis used in geology, in geological sciences, and I hope I represent because I am not a pure geologist. So geology can be very wide and we will see through different cases. So previously on biology, I show you how to calculate indexes. And then the indexes have to do analysis, for example, t-test to look at the differences if we have two variables, right? So on, why did I open coral bleaching? Salah buka file. Sorry ah. Salah file betul lah saya. Sure. This one. Okay. So on geological perspective, I think in UMT we are quite strong, especially when we want to look into the beach profile. I think Dr. Effie represent very well on beach profile, and then we have paleontologist by Dr. Hasriza in the group, and then we have Dr. Adley, and then hydrology. So actually geology is not only on grain size, not only on sediment core. So it's actually the coastal processes is related. So I have to speak from the notes because it is mainly somebody else's field. But to understand the ocean system is to quantify the interconnectivity of all these components. And in the 2004 understanding is that such an understanding does not exist. That was in 2004. This is one of the report that I have found online. But then for 2004 until now, there are a lot of recent technology, recent advancement. For example, somebody posted on the chat room is plate tectonic, like Dr. Hafiz, how he looks at Antarctic and how does sea level rise and sea level changes. How do we know the differences throughout time? One of the things that I can see from geological component is that we have to monitor a very large area, and it need to be monitored in a certain period of time. Whereas biology, even though we can have a very wide area, we still need wide area, but the time frame, it can be settled down in between 1 or 2 monsoonal season. For example, if we want to look at plankton reproduction, you can have sampling for 3-4 months, maximum 1 year and a plus, minimum 1 year and a plus. You can see the full cycle because it goes on. But when we talk about geology, it is a very long time frame. That's why most of the time is ocean sediment core looks at how does each core that were collected from the component of geology represent the previous, and then after that we can model out the future. Okay, so what happened is that I'm going to go through case study by giving example of what are the cases that we can see, because there are a lot of things that can be described. Okay, so for example, case one here, this was a paper by Mark Johnson, Stratigraphy Sedimentology Age. So this is pure geology. When we talk about stratigraphy and sedimentology, is how does sedimentology changes over time. So if for example biology, okay, for biology, for coral we have sedimentation rate, accumulation of certain particles. Means like my field, I'm talking based on my field, is that for example coral reef, you always have runoff coming up from the river, and then of course the sediment deposit into the reef. So it doesn't deposit a lot, but then after 1-2 cycles you can see the coral, maybe like in Langkawi or in Port Dickson, they are covered by sediment. But in Sunda Shaft, for example, accumulation of particles or sedimentation rate means the amount of sediment actually deposit in the deeper oceans. For example, our Mariana Trench. Over a long period of time, every year there would be sedimentation, means the particles from the surface, it can be diatoms, it can be calcareous organisms, or it can be runoff. It can be the movement of the tectonic plate in 1000 meter, or the component of particles will actually deposit to Mariana Trench. So Mariana Trench is about like 13 kilometer deep. So maybe after 10,000 years later on, Mariana Trench might be not that deep because sedimentation does happen. So for example, this project by Mark, what they do is that they want to look at the changes of sedimentation at an area of Swedish area. So what they do is that they drill sediment core. So sediment core can be drilled in the ocean, or it can be drilled on dry land, depending on where is it. So for example, sea level rise are higher 5,000 years ago. So if you want to look at the changes of geomorphology and stratigraphy, we can actually core one sediment host within UMT area and look what is the changes of these 5,000 years. Okay, so for example, these two cores were taken from this K Kola Garden and then the M Mellemarken. Okay, so what happened is that they drill holes and cores. So when they drill holes and cores, they can compare the differences. So if you look at the top of the surface, between 1 to 2 meter are mainly the core sand. And then after that, go down and then you have sand. After 8 meters, after 10 meters here, it more to be clay and deformations, means it become very small particles. So when we talk about geology, a lot of the time, geologists work with rocks and work with sedimentology, means the type of grain size. Okay, and the type of grain size can be like large to very small until fine sand. So we can see from K to M that there is a big differences. Okay, big differences of the sediment core itself. And how do they define is that look one by age. Okay, how do we determine the age of sediment? Chat room, answer. How do we determine the age of sediment?
Login.
Ya, tak dengar. Tak dengar tadi. Core. Yes, we take core, but the core logging, carbon reading or something. Anissa. Okay. One is by carbon. If we have carbon content in the sediments, carbon contents means it need to be calcium carbonate or calcified organisms to look at the carbon content. Usually they use uranium, thorium, okay, uranium, thorium, or we can look at polonium and lead isotopes. So we use isotope. Forum also look at the age of the forum itself. It's not the forum, the type of forum indicate the age, but the forum is used to detect the carbon dating. So we date the age of the sediment core. Okay. So for example, in this study, these two, the K and the M, they can be in the same length, same depth, same kedalaman, 9 meter depth and 9 meter, but the age can be different. The age here may be, I'm not sure, but then the age can be carbon dating, because if I see this, if I look at the sediment core itself, the gray, the pinkish and the gray color, the clay, started at 8 meter, but this one start at about after 10 meter, after 15 meters. So I would mention that this age is similar to this age. So because by the profile is different. But when we look into analysis, data analysis, this is something that I am also learning together with you on geoscience. I don't see the statistic that we have learned before are being used. Okay, I don't see the ANOVA, I don't see t-test, because on geological component, this already indicate straight away what is happening. Okay, it cannot saying that, oh, I take 5 and then I compare what are the differences, because they don't look at the differences, they want to know what happened before. Maybe tak berapa faham, but then I'm trying to explain here is that, for example, grain size deposition, like what kind of grains deposit a certain area. So from the results saying that how many percent, of course this is like calculate the indices, biology indices, and it's the same that it is just calculate the percentage. Okay, in a total of 100 kilogram of samples, can be biological, geological, or chemistry samples. Then after that, you proportion it and then you find the percentage. So in mineralogy, they show, for example, this figure A that shown in here. This is figure A. Okay, what they say, they're showing a statistical significant difference. But then it is not the t-test, it is not the ANOVA test. It is just telling us that the composition is different. So once it's different, it is, in geology, it is statistically significant. Okay, but in biology, our significant, the p-value must be less than berapa? answer in chat box. The p-value must be less than at least
0.5.
0.05, not 0.5, 0.05, means 95% of the data, right? But it was not used in geology. So when we talk about geology, it's kind of little bit hard for me because I am used to all the statistic tests, but it wasn't shown. So what happened is that in geology, a lot of the time is that we look at the grain size. This one, I gave you the PDF file. I think this is more to recap like what is grain size and how to interpret the data and then the type of statistical analysis. And if you read this article, the statistical analysis have not touched in the t-test, the ANOVA test or whatever test, but it is more to what are the skewness or what are the log interval, and then there would be anomalies of +1, +2. Okay. I will show you in the next few slides. So for example, this case study number 2, okay, by this paper by Estonian Journal of Ecology on grain size analysis. This is very geology based paper. So when you look at this grain size, it was categorized, okay? But once it was categorized, we cannot draw the figure of category. So I'm going to try to unmark. Okay, so when we have, because when we look at grain size, there is category 1. This is clay, category 1. And then silt, there are 2, 3, 4, 5. Okay. But then we can, the problem is if we draw the line as 1, 2, 3, 4, 5 or whatever until how many? 5, 6, 7, 8, 9, 10. 10 here. Okay. You will see that the graph would be presented like this because the peak is at 5 and 6. Okay, this is 5 and 6. So if you want to categorize by this, you will see that it is normally distributed. Okay, if you look at this graph, it's normally distributed. Betul tak? If you learn from Dr. Chung's class, if you remember, how does the grain size distributed? But we cannot categorize here. It must be categorized by the grain size of micrometer. Because then we can compare if this is the size of clay. So this is the length that we need. So if you look at this figure, what kind of figure, how to describe this figure? This where's my, it's always, okay, I would clear, so how do we describe the figure of this? When, if in the geology, you have learned to describe, the first is to describe the graph. How to describe this figure? Just now I give tips, is like, if it is by category, it's normally distributed. Okay, but we cannot put it in category, we must put them in grain size. So in grain size, this figure is called answer in chat box. No, no response. Do you all want to try? I takut I tak ada line saja. What kind of figure is this? If this is not normally distributed, then the data is called skew to the skew to the right. Yeah. Okay. Betul. Pandai pun. Anissa, kenapa skew to the left? This is right. This is right. This is left. Okay. So now you can know that your okay, now you know that the grain size, if it's skewed to the right, means that it is more to sandy, means the bigger, largest size. If it's skewed to the left, means it is more to fine particles. And how do we want to interpret is that, for example, this figure is to look at the differences of the grain size from different treatment. So we know that this kind of treatment, these two are more skewed to the right. These two are more skewed to the right. And then H2O2 are normally distributed. So it doesn't go into any category. Okay. All right. Next one. Let's try to analyze the next one. Okay. So if this figure were given, what kind of distribution of grain size? What is the distribution? Skewed to the left. Okay. So now, just now that the top two was skewed to the right. Now, now this one another. These two are now skewed to the left. And then after that, this HCl, this one is normally distributed because it is still in the middle of the figure. And one of the category are skewed to the right. So this is how geologists look at how to calculate and how to describe. So in this figure, we cannot do tests like, is there significance? Is there any significance of these two treatment compared to the other treatment? Where's my mouse? Yeah. Okay. This one. If this is a biological sample, so this is treatment. This bear with me, computer sudah gila. Okay, so this is, for example, treatment 1, treatment 2, treatment 3, and treatment 4, right? So now we know that treatment 1, treatment 2 is skewed to the left. Treatment 4 is skewed to the right. Okay. If this is a biological data to look at the distribution of plankton or distribution of corals in island 1, island 2, island 3, and island 4, of course, biologists would ask you, is there significant difference? Then we have to do ANOVA test because there are more than 3 islands and then there are more than 3 variables, so that we want to test if this island, where is my mouse again? If these are different, so we have to do analysis of ANOVA if this is biology, and then we want to look at the p-value if 4 is different from 1 and 2. This is what a biology look at figure. But on geology, as long as these 4 are totally different opposite from 1, 2, one skewed to the left, one skewed to the right, that is already telling us that is a differences. Okay. Very simple. I think geology data are more simple by looking at figure and the figure were being described. Okay. So the next one, this is very similar to the calculation of our indexes. Okay, these calculations are the same if you want to calculate the abundance of fish, abundance of plankton, abundance of crab, abundance of giant clam, whatever abundance, is that you have to categorize them into different species. But under geology, it was categorized as different grain size. So there are category of the sheaf. Okay, so you can see there are different size of the sheaf that you learn from the shaker, that you shake the grain into different component and different size. And then after that, you put into your weight. Okay, you can weight together with the sheaf, and then you calculate the total amount, and then you calculate the percentage. The percentage at the end here, at the end must be 100% cumulative. Same for calculation of biological diversity and abundance. So it must be 100%. It is just that the category are different. So I want to compare it, giving you example of what are the differences with biology is that if this is biology, so you would count by, okay, this is fish, fish 1, fish 2, fish 3, ikan kekek 1, 2, 3, 4, 5, 6. There are 21 type of ikan kekek. Kan? I was not listening to me. 1 to 8, and then after that we calculate how many fish. And the calculation is that maybe we can have 1,234 fish. Okay, so it must be, and then we calculate the total, and then this is x. Okay, so your x equals to 1, 2, 3, 4 times 100%. That would be your total abundance. And when you calculate cumulative, the percentage, it must be 100%. It is the same table, it is the same concept of how do you want to calculate the percentage. Okay. Did you okay until here? Give me sign okay if you are okay. Faham kan? Internet problem so bad.
Betul.
Ha, ya.
Yang nak tanya lah, yang X bahagi 1, 2, 3, 4 darab 100 tu untuk cari apa tu? Sebab tadi saya punya sekat-sekat lah.
Saya pun rasa macam saya tanya soalan tersekat-sekat. Calculate the percentage abundance. Percentage. Kan? This one is your percentage. This one. Boleh tak, Maldin? So it's like
Faham.
So it can be grain size data, it can be biology data, it can be chemistry data. When you want to calculate the percentage, you just need to know the X and the total of X. Okay? Faham dah kan? Okay, next one is Where is my mouse again? This suka lari tak tahu ke mana. No, I cannot go. Okay, so I have to stop. Okay, now it comes up. Right? Okay. The next one would be okay. I have to read and explain. Even with the complete understanding of today's ocean, so we have very limited understanding of the current oceans, especially when we look into large oceans, for example, Pacific Oceans, even our Straits of Malacca, we don't fully understand what is it in it. So for example, we want to look at the plastic distribution. Okay, we have to look at the distribution of the plastic in the Straits of Malacca. It is more to a very long-term processes. And geology usually is to understand the past. That's why we take a lot of sediment core, coral core, ice core, a lot of things that we can determine the past. So in the past oceanic condition, there would be deep sea sediment, ice core, shallow deposit from lakes or bays or even corals to understand the past and the present. Okay, and to future climate change fully. So to understand what is happening to the climate change in the future, and we must understand the long-term natural variability. So this is one thing that I always share to the other class on coral reef is that, for example, coral reef, we use a lot of satellite image. Okay, and the satellite image technology, even though for our generation, we think that it is long enough. Okay, long to show what is the differences. But for geological component, for geology, 200 years old is young. 300 years old is young. The age is for millions of years. So we want to understand what actually happens in an ocean system over time in the long. Okay. So one is that we want to use all these, the sediment, the ice core, the coral cores, to reconstruct previous. Means we find information from the previous. So one case study that I want to share with you is that one of the publication that me and my team did. Okay, if you look at on my project, you will say, Dr. Jenny buat coral are biology. Yes, coral is biology, but I'm looking at coral cores. So cores is geology. And from the coral cores itself, it gives us a lot of information. Okay, so I gave you the plain language summary because the scientific summary is quite scientific enough. So we want to reconstruct the luminescence measurements from coral cores. Okay, so one of the example that I can give directly, for example, this is the sample collected at Kuching. Okay, Pulau Talang, Sarawak. So what happened? This is the coral core. So coral are like sediment, same like sediment core, ice core, because ice core have different layers. Because during winter, the ice would deposit. During summer, the ice would melt and compact into a layer and every layer. So every year they have different layer. That is ice core. Even for tree rings or sediment, also have layers where you can see from the previous case study is that you can see there are layers of different minerals because, for example, in Pulau Bidong, for example, year end where we have high rainfall, a lot of flush from the river, there will be deposition of the silt and the clay component. But during summer season, there will be less deposition of clay, and then there will be deposit of more to a larger grain size. So even though it is very small, but you can see that every every course, any course that we collect, there would be layer. So for example, this core that the coral core, only the top are alive. Only the top part is biological. At the bottom is all calcium carbonate. It's all limestone and it's all geological component. That's why I am part of marine science, because I do from biology, geology to chemistry and chemistry lah. Physical tak buat. Alright. So what we do is that we take the core and we want to relate it. This is luminescence. Luminescence means under ultraviolet light, there would be different color. The light blue intention is that it is due to rainfall. Rainfall, higher flush out. So we want to see the intensity. Look at this. You can see that actually our data show, okay, this is from the previous luminescence. Okay, so we look at the luminescent intensity throughout time from the coral core and understand what happened before. So the coral was collected in 2014, and then this is the track back, means we use the past, we understand the past to know what is the model, and then we predict what happened in the future. Okay, so after all this, our regression, you can see that we want to know the luminescence and the intensity, the luminescent intensity compared with the satellite, the CDOM, the total carbon organic material, and we look at the relationship R square is 0.5. Even though Dr. Chong did mention that R represent the relationship of the X and Y. If the R value is 0.1, it is a weak relationship, but if it's significant, the P value is less than 0.05, then it represents that the X are dependent 0.1% to the Y. Okay, so this is part of some of the analysis that from my work that relate to geological component and how do we analyze. Okay, so we reconstruct the previous, and then we can predict in the future the luminescence would be greater if there is rainfall. Okay, case study 3 done. Are you okay with this? Okay, Maudine will present everybody kan. Maudine give thumbs up means everybody understand. Okay, so the next one, Faris pun okay. So the next one is when we have all this, when we talk about geology, it is on the grain size, it was on the core. So we want to also to know what happened to the ocean, in the larger ocean or in a larger component of the studies by some of the geologists that have worked in Malaysia. So I gave you example, understand the concept and design of the following articles. And these both articles were given from your, in your e-learn. Okay, so one of it is by Dr. Effie and his team. So a short-term observation on beach morphodynamic during seasonal monsoon from two different coastline of Terengganu. If you look into the journal itself, it describes clearly what are the beach profile of A and B, Ibai and Pengkalan Maras, KI and the Pengkalan Maras. It shows us the differences, but it's as I mentioned before, when it shows a very clear differences, it doesn't need any of the statistical test. It is more to describing the figure and the differences of the beach profile itself. Okay, and then After that, there would be character, this one. Let me go back. This one, if you look deeper into it, is that it was determined by the domination by cause and find sand. Okay, so this is described. Sometimes descriptive statistic is very important for us to describe. Sekejap, ada phone call. Hello, I call you back. Got class. Okay. Sekejap, aku ada kelas. Ada. Kat rumah, kat... Okay. Kejap. Ya. Okay, so what happened is that you can see that, what did I mention? It was not on the test, but then descriptive statistic is very important to describe the differences of grain size or beach profile or the grain analysis. Okay, and then the next paper that I gave you is more technical. This is by Dr. Adlik and his team, by looking at climatic and tectonic control on chemical weathering. I think this one also more to descriptive. If you look at the abstract, it shows us what are the percentage of clear mineral assemblage. So you can see that average 80%, Sumatra is 58 to 78%, and then Borneo, North Borneo. So by looking at the differences of percentage already gave us a view of what are the differences. But then under geological component, we doesn't need to have tests. Is it significant or not? Because we doesn't need to know is there any significant differences of the clay. But under biological, we need to do the test. If our test is significant difference or not, because biology samples are representative to a biological component that can move and that can travel, but geology are more to grains that cannot travel. It is there. So like you come to my house, you can have this 2-story house. It cannot move. It is a stagnant component that how to say that doesn't need to be proved. Is it yes or no? It is like I bagi you seketul batu, that is the batu. I cannot change the batu into a piano. I cannot change the batu into a laptop. But biological component, that fish, they might have variation because the fish dia kurang makanan, dia kurus sikit, nanti dia lebih makanan, dia gemuk sikit. So they have variables and differences. But geology, it cannot change like a biological component. Okay. Apart from this, I think that's all for the notes. But I'm going to keep out a little bit on some of the articles just to show you what are the differences that we can see from different kinds of journals. Okay, I think this is very technical and I wanted you to read, but then it is too mathematics and too statistics. So when we look at beach profile, there is statistical process, but the statistical process is not ANOVA, but this statistical process is called a SPA, a statistical process based approach, where I will show you. This is all the calculation. This is all the calculation, the U stirring or the alpha max, and then after that it is still the differences of, where was it just now? Tak nampak dah saya pun. Okay. Here. Okay, so if you look on the calibration, the parameters that was given are usually factors of skewness. Is there symmetry of the data itself? So this is the kind of geological statistical modeling, and I'm pretty sure if we continue on to look at coastal processes and oceanography geology component, the lecturers from the geologists would have a better explanation of all this. But I would just, as I mentioned just now, skewness is very important in geology. So you have to understand what type of skewness of this grain size analysis. Okay, and another one is this one. Okay, the next one is this one. I think this is, even though just now some of you said forum, I understand under geology now that Dr. Fatin and the group are doing forum minifera and reef forum minifera as bioindicator of the coral reef. So this is more between biology and geology. So apart from using biological component as a reef health, Dr. Fatin and the group use forum to determine the coral reef health from forum itself, from the geological component. So if you look at the statistical analysis, this is all very biology, like 8 orders, 41 family, how many species that were, and then after that, how many percentage? The percentage is the similar of the percentage abundance that I mentioned. And then this is the kind of data that you can see, diversity indexes. This is where we have learned previously on biology, how do we calculate the number of species, the Shannon Minor Index, the Polo evenness, and the Fisher Alpha. So there are a lot of biological indexes throughout time. Okay, and then percentage of the rest. And then after that, this is the forum that I discovered. Of course, they also have geology, the grain size. If you can see how many percentage of the samples that were collected is organic matter percentage. And then what are the distribution of the sand? Okay, so coarse sands means they are more to sandy, and then mud are more to silt. And if you look at all the station, the mud means the smaller particles are always the less percentage. Okay, apart from 1 or 2 sites, for example, F2, where you have higher, a little bit higher, but it is still not the major grain size. Because if we have mud in a coral reef area, means the health is not that strong, because mud can always deposit and redeposit into the coral itself. So the more mud is it, they are more destroying to the coral reef. And of course, this one we didn't teach, but I just want to show you how does it relates from biological, the forum, the sediment, okay, and the water quality. So the forum index and the water component. So this is how an analysis was done by Dr. Fatin and the group. Same for CCA, means they want to categorize what kind of the X is organic matter, and the other one is the species. So this is the species. So if you can see here, these species, yeah, are more dominated at the higher organic matter area. And then these species are more related to the bottom water temperature. So this is how biological and chemistry components are being linked and being analyzed in statistics of CCA. All right, this is grouping. I'm not going to go through this, but I want to show you that. Okay. If you look at the data and statistical analysis, it was saying that they were using cluster analysis. They were using different kind of statistical diversity index using the past paleontology statistic. And this PAS software only works on a Windows computer. Okay, it doesn't work on a Mac. So I didn't teach this, but supposedly we want to teach. But if you go and look into eLearn, there is one link to download PAS, and PAS can actually can do a lot of indexes, and they can calculate the abundance exactly very similar to R, but it is between SPSS and R. So it is like a table form, then you can key in your data and then it generates figure that is needed. Okay, and then after that, forum index. So index is also very important. Index is something that you want to know the differences of side A and side B, but still have to do tests if that two index are different. Is it significant or not different? Okay. And one last is that this paper by, okay, this is on grain size analysis. So I'm going to give you again one last question before I leave. I end the class. Is that how do you want to describe this figure now? Let me take back the chat room. Okay, how do you want to describe the figure of grain size distribution? Skip to the left. And this was before, now it's already 352. How do we want to describe? A, skewed to the right, yes. So if you can see that if R to H is a time zone, okay, this is not by time, this is by distance. But if it's a distance or a time, you can see that it is keep on skewing one to the other, getting more to larger grain size. Skewed to the left here is larger grain size. So for B, Maldin was mentioning macam equal. So for geology, you doesn't need to say macam-macam. It was R1 is normally because it's in the middle, and R2 are still skewed to the right. Okay, as long as you take the figure, you draw a line of middle. If it's more middle, then it's normal. So if it's to the right, so it's larger, and if it's to the left, it is a smaller grain size. Itu sahaja. Very simple on geological descriptive statistic on grain size analysis. Okay. Okay, I have given you a lot of example, and I hope that the example is enough for you to understand the geological data analysis. Are you all okay? Okay, so I just want to, that's all for geological indexes, data analysis. I will stop sharing now. Okay, so I just want to make announcement. My announcement is that this Thursday is your test. Yay! I have given you tiba-tiba banyak reaction. Tadi I tanya soalan tak ada reaction. So I have given you the schedule since the early of the semester. And then after that, it was really mentioned here that this Thursday is your test. The test is very simple. It's online. And then it's multiple choices. Modin jangan tersenyum-senyum. multiple choices. There are about 25 to 30 questions because I am still creating questions. I'm going to open it for 3 hours. 3 hours of your lab time, 10 a.m. to 1 p.m. But each student only have 60 minutes to answer. So if you start at 10, you would stop at 11. So if you start at 10:30, you will stop at 11:30. So make sure that that 1 hour, your internet is strong enough. Itu sahajalah. Okay. Right. Any questions on your test? Okay, if there is no question on your test, I don't see you this Thursday. You just go e-learn and do your test. Then I'm going to see you next Sunday. We are going into chemistry. Then next week, I'm going to give you the tutorial on chemistry and geology. Ada calculation ke, Doktor? Yes, ada. Dr. Chong ada sediakan soalan-soalan. So sediakan calculator. Tapi the calculation is simple lah. Tips your median lah, your mean value. How do you calculate your mean, your median, your minimum, your maximum. The basic. Okay. Alright, gonna stop recording.